Okay, so these next few examples we're going to look at, finding the domain, the vertical asymptote, and horizontal asymptote for the following rational functions. Okay, now the domain and vertical asymptotes, they're going to be related in a sense where the domain is pretty much all numbers that, as long as I'm not dividing by zero, and a vertical asymptote um, will occur, at least in these examples, whenever we're dividing by zero. Right? As we'll see, in some cases we'll have a hole in the graph, and there we'll be dividing by zero, but another piece of the numerator will also be zero, leading to an undefined value. Okay, but again, that'll get into at a different time. But for now, we'll take a look at finding domain, vertical asymptotes, and a horizontal asymptote. This has to do more with end behavior. All right. Okay, now when we look at this, and I'm trying to find domain, the first thing I'm going to focus on is the denominator. All right. It's already in factored form, right? So I don't have to worry about factoring anything. Right? I want my rational functions to be in completely factored, both the numerator and the denominator. Right? In this case, our variable only shows up in the denominator, so I'm going to find the value that makes the denominator 0. All right? I only have one linear term here, so solving for x, we get x equals to negative 2/5. So when it comes to the domain is going to be all real numbers except this number. Now, using interval notation, that's equivalent to writing, all right, negative infinity up to negative 2/5, but not including 2/5. All right, I want to exclude that from my domain. And then I'll write a union symbol, and it'll be approaching 2/5, but not inclusive of 2/5, negative 2/5, and then going off to infinity. All right, that would be my domain. Right now, the vertical asymptote, that occurs where the value is, I'll just say VA, vertical asymptote. All right. Now, the next thing is to look at the end behavior. Right now, as x goes to infinity. Oops, sorry, negative 2/5 here. My apologies there. All right, now, when we take a look at these very large values, right, what I want to think in my head, and even write it down if you, to help you out, right, as the x approaches infinity, right, what's going to happen here is the leading terms are going to take over. Okay, so when we see what I'm saying by the leading terms now, the numerator, there's only one term, so that'll just be 2. In the denominator, the leading term is at 5x. Okay, so we get 5x, right? Now again, this is only for as x goes to infinity, for large values of x. Right, we see x here, it is similar to the behavior of 2 over 5x, and when I only have a x in the denominator, I want to think of my toolkit function. Right, this is just kind of a constant here, but my toolkit function, when it's like 1 over x, right, what did that look like? That looks something like this, right? So for end behavior, this exhibits the same behavior. Right, so as x goes to infinity, we see that f of x approaches 0. Right, and we could say the same thing as x goes to negative infinity, right? Because it has this same behavior, and the same behavior of my toolkit function here, negative. So it goes to f of x goes to 0 as well. Okay, and again, here, and the reason for that is that the 2 is that this value of 5x takes over, right? It's more dominant, right? Think for large values, let's say x was 10,000, right? That plus 2, it's not going to make much of a difference to the value, right? So we can just approximate it by 2 over 5x. So that's kind of the thought process behind that, right? That as x goes further out in either direction, right, the values that are not the leading terms, they kind of they're not as heavily influenced. They don't heavily influence the function anymore, right? They have a lot of influence in the local behavior, right? But as we go further out, what takes over are the leading terms. Okay, let's do an example here. Another example. All right, so our goal here is the same thing. All right, so for this example, I want to find domain, vertical asymptotes, horizontal asymptotes. Okay. All right, so our function here is going to be f of x equals to 3x minus 4 over x cubed minus 16x. All right. Okay, and again, I want to have this in factored form. All right, so factoring this, the numerator is already factored here. Here I'll have an x as a common factor, x squared minus 16, and 3x minus 4 over, this is a difference of squares, so x minus 4, x plus 4. Okay, all right, so now the domain, right? So I want to focus here, where notice that no factors cancel out, so I don't have to worry about that. Now the domain, and this is why I like it in factored form, right? I'll look at my denominator, and where does that equal to 0? And we see we have all our terms here. We could say x is 0, or x equals 4, x is equal to negative 4. Right, and these are also going to be my vertical asymptotes. But these are also the values that are excluded from my domain, right? That's division by 0, so it's undefined. So when writing the domain, right, it's going to be for negative infinity. And here our first value that we come across that's undefined is negative 4. Right, so I want to exclude it. So essentially union and then start again by negative 4, right? All that does is removes that value of negative 4. The next undefined value I get is here, this value 0. And again, same thing. And then the next value is 4 here. All right, so that's how we can write it using interval notation. Okay, so now the next thing is to determine is our horizontal asymptote or our end behavior. All right, so here let's take a look at our end behavior. So I'll take a look what happens as x approaches infinity, right? Now again, for something like this, I'm going to focus on the leading terms, right? As x gets really large, I can think of this function as just being the leading terms. For this, I'll look at the non-factored form. It's easier to see the leading terms there. So that'll be 3x over x cubed. Right? And I can do some simplification over x squared. Right? And again, that's my token function, 1 over x squared, multiplied by some constant 3. But in general, this looks like this. Right? Asymptote at x is equal to 0. Again, but the important thing that I want to get from here is the end behavior. Right? So the function behaves similar to this. Right? So as x goes to infinity, f of x goes to 0. And the same thing in the other direction. Right? As x goes to negative infinity, f of x goes to 0 as well. All right. And that's how you find the domain, the vertical asymptotes, and the horizontal asymptotes. Thank you.